Hi guys, welcome to another video. Here we have been asked to find the derivative of function 3x squared minus x using first principles. That's the keyword. Now, anytime you hear the word first principles in finding the derivative, always think of this function that I've written here, which defines the derivative, which is also often written as dy dx, as the limit to which this gradient function tends as values of h go closer and closer to zero. They never really get close exactly to zero, but it will show you the limit of that function. Now, you may have come across the gradient function in earlier work as defined as y2 minus y1 over x2 minus x1, right? As a rise over run, which is also considered as a change in y resulting from changes in x. Now, these changes in x in this in differentiation considered very small and also sometimes written as delta x. Now, remember the function we've been given is 3x squared minus x. So we're imagining a point x and then a neighboring point very close to it. We're basically increasing the value of x by a very small amount, f of x plus h. So this f of x plus h is going to be, anywhere we see an x, we're going to replace it with x plus h squared minus, again, the x plus h. So therefore, our derivative is going to be equal to the limit as h tends to 0 of this function, now replacing the appropriate values. So f of x plus h is going to be 3 multiplied by x plus h squared minus x plus h minus, in our formula, minus f of x, and we know f of x is 3x squared minus x. All of this is divided by h, close our bracket, right? So now this, the limit, sorry, I'm writing that word there. Let's expand the different brackets. Now, x plus h squared, you can imagine that as a plus b squared, and we can expand that product. It becomes, this is basically a squared plus 2ab plus b squared, right? So this is going to be x squared plus 2xh plus h squared minus x plus h minus 3x squared minus x. All of this divided by h. Derivative is going to be the limit as h tends to 0 of, now let's further expand this. So this is going to be 3 times x squared, 3x squared plus 2 times 3 is 6xh plus 3h squared, right? Minus, let's just clean these up a bit, minus x, we open those brackets, minus h, minus times plus 3x squared minus 3x squared, minus times minus, that's plus x squared. So we divide all of that by h. Now in the next step, we can see how some of the values cancel each other, right? So 3x squared can cancel minus 3x squared. And we have minus x can also cancel. Sorry, this was originally supposed to be x here. Yeah, so we can rewrite this as the limit as h tends to 0 of, now we have 6xh plus 3h squared minus h. Yeah, so basically that's it. All of this divided by h, and we can further clean this up, dividing each of the terms in the numerator by the denominator. So our, let's get some more space. Our derivative is the limit as h tends to 0 of, now h cancels h, so we have 6x plus 1h, h cancels 1h here, so we're left with 3h minus h cancels h, so minus 1, right? So now the limit, as the value of h gets closer and closer to 0, we can see that it becomes 6x minus 1, right? So therefore, f of x, our derivative, is equal to 6x minus 1. Okay, so this is our answer. Now, to prove that that's correct, we can use the general method. So remember, our original function is equals to 3x squared minus x. Usually, to find the derivative of a term, we multiply the term by the exponent, and then we decrease that exponent by 1. We do that for each of the terms, okay? So 3 times 2 would be 6. 2 minus 1 is going to be x raised to the power minus 1, right? Minus, you imagine there's a 1 on the x. If a term doesn't have any exponent, it's exponent 1. So 1 times minus 1 as well. We assume also there's a 1 here, so that's going to be 1. But if we decrease this exponent by 1, it's going to be x raised to the power 0. And x raised to the power 0 is just 1. 1 times 1 is just 1. So therefore, we have the same answer here. I hope you found this useful. Follow me for more.